Well, again, in this lesson, we're going to be talking about domain and range, but when looking at equations. We're really going to consider two equations for this lesson and focusing on them for what happens to the domain and range. The one is going to be rational equations. So rational equations are things where we have a fraction and there's a variable in the denominator. So let's consider the example y equals 1 over x. If y is a function of x, then what values cannot be included in the domain? What values can I not substitute in for x? So what would make this a problem? I can, you can think I could put 1, I could put 2, I could put 3, I could put decimals, I could put like a half in there, I could put 0.5 in there. But the thing I cannot put in there, hopefully this came right to your attention, was 0. You can't put 0 in there because that creates division by 0. So we could therefore say that the domain is all real numbers except 0. Since we can't divide by 0, 0 can't be x. That's not part of our domain. Now, if we cannot include 0 in the domain, then what values cannot be achieved or included in the range? So you can start trying to experiment and guess, but if you think about the fact that the numerator of this function is 1, if it's 1, then no matter what we do, we can't change that 1. The x is in the denominator. No matter what we do to the x, the numerator will always be 1, so we can never make that equal to 0. So therefore, the range is also going to be all real numbers except 0. Now, we'll see that the domain is going to vary a little bit more coming up here, but the range is going to typically be this all real numbers except 0. Okay, so what does this look like if we go ahead and graph it? So using this function y equals 1 over x, we're going to plug in these values and create a graph of what we have here. So if we plug in -3, we get negative 1/3. Here we get negative 1/2. Here we get -1. Then -2, -3, -4, -5. Ooh, this doesn't exist. Sometimes you'll see DNE for does not exist, so we can't do this. We'll come back to that. If we put in 1/5, we'll get 5. We put in 1/4, we'll get 4, 3, 2. Here we'll get 1, and then we'll get 1/2 and 1/3. So we start to graph those points down below. We go over to -3, and that's at -1/3, so call it about there. -2 is at -1/2, so about there. -1, -1 right there. And then -1/2 should give us -2. Move that over a little bit. And -1/3 will give us -3. -1/4 will give us -4, and now it's really getting splitting hairs here, but something about like that. All right. And the other, we can't graph this 0. There's nothing that happens at 0, so nothing on the y-axis. Okay, and then 1/5 will put us up at 5, so I'm going to call that about there. 1/4 at 4, 1/3 at 3, 1/2 at 2, the point 1, 1, the point 2 and 1/2, and the point 3 and 1/3. So hopefully you see some sort of pattern here. We're going to connect the dots. We could have put points in between here. I'll do my best. A little bit tricky here. I'm going to try to make it curved. And very key in this when we're drawing our curve is to remember the fact that since it does not exist when we plug in 0 for x, these lines will not cross the y-axis. They also won't cross the x-axis. We could spend a little bit more time talking about why that is, but if you think about it, you can't. We said we can't achieve 0 for either the domain or the range, so that can't happen as well. We talked about the numerator has to be 1. So that's our graph. They should look much more like nice curves than mine, but you get the gist. So that's our rational equation and what it looks like. The other one we're going to consider are radical equations, equations that have a square root in them. We're just going to stick with a square root. We're not going to get into cube roots and fourth roots and things like that. Okay, but if y is a function of x, then what values cannot be in the domain? So what can't we put in for x? Well, hopefully when you're thinking about the square root, what can't go inside there? We can't take the square root of a negative number. So if we can't take the square root of a negative number, how can we write that? How can we say what the domain is? Can we take a square root of 0? We can do that. So we can say the domain is x is greater than or equal to 0. Because it can be 0, it can't be anything less than 0, anything bigger than 0 is totally fine. So if we take square roots of that, then what are we going to get out as our outcome? What values could be in the range? If this is too much to think about, you can go ahead and graph it, and it'll help you kind of reveal that. But if you think about taking the square roots of positive numbers, we're going to get positive numbers back. So again, we can't have what cannot be in there? Negative numbers again. So our range is going to be y is greater than or equal to 0. So let's go ahead and take a look at what this graph is going to look like. Square root of 0 is 0. Square root of 1 is 1. Square root of 2 is a messy number, but it's about 1.414. Calculator for that one. Square root of 3 is 1.732. Square root of 5 is 2.236. Square root of 7 is 2.693, and the square root of square root of 9 is 3, of course. Omitted square root of 4 is 2, of course, in there. I'm not sure why I chose that to do that earlier. We'll throw that in there as well to help us. Okay, so let's go ahead and graph this. So we do have 0, 0 right here at the origin, and we have 1, 1 right there. Then we have 2 and 1.4. We have 3 and 1.7. And then we have 4 that lands us right on 2. 5 that gives us 2.2. And then we're skipping a line to 7 to give us 2.6. And then skipping again to 9 to give us 3. So this graph looks curved, and it kind of grows flatter as we go this way. Try that again. And so that's the graph of the square root function. So let's go look at some examples about what you might be asked to do in terms of domain and range in your homework. So here's a few that we're going to try together. So here it's not just 1 over x, but you should recognize that it is a rational function. So for rational functions, we can't let the denominator be equal to 0. So let's make up a tiny equation. I'm going to say x minus 5. In fact, though, I'm not going to say equals. I'm going to say cannot equal 0. Well, let's go ahead and solve this by adding 5 to both sides. So we get x cannot equal 5. So for our domain, we're going to say all real numbers except 5. But now what about for the range? For the range, remember the numerator is still 1. We can't make that 0. So even though the domain was a little bit different here, the range is still going to be all real numbers except 0. Really, we'd have to be adding numbers over here to our equation to change that, but we're not going to really be messing with that too much this year. We'll save that for next year maybe. Okay, this next example, another rational. The denominator, x plus 3, cannot be equal to 0. Subtract 3 from both sides. X cannot equal negative 3. So our domain would be all real numbers except negative 3. Our range, still all real numbers except 0. That's again because of the numerator there. Okay, let's look at some examples with our square root functions. So we said for these that the inside is called the radicand. I should have mentioned that earlier. The radicand must be greater than or equal to 0. So let's set up a little inequality. X minus 5 greater than or equal to 0. So we'll go ahead and solve this by adding 5 to both sides, and x must be greater than or equal to 5. Well, that's exactly what we're going to put down for the domain. X must be greater than or equal to 5. For the range, we're still going to go ahead and say that the range is just y is greater than or equal to 0. Let's look at another example here. We've got the square root of x plus 1. And again, we're going to just say x plus 1 is greater than or equal to 0. Subtract 1, x is greater than or equal to negative 1. And that's going to be our domain. And our range is still going to stay basically there as y is greater than or equal to. Now, if you think about putting in negative 1, you would get 0, so that's another way to think about that. We could get 0 still here. Okay, so there's more examples below, and those will be exercises for you to try in your homework. Watch out for some tricky examples coming up. Do your best, and good luck.